Hi friends, welcome back to my channel. In this video session, I am going to solve week 7 assignment of advanced computer architecture. So friends, let's see the first question. Question number 1. Which of the following statements are correct? Statement 1. Most modern NVIDIA GPUs use the single instruction multiple thread model. Statement 2. A RAP is a group of threads that are scheduled together on a streaming multiprocessor and are executed in lockstep. Now here both statements are true. Okay, so I select that one. Now moving into the next question, question number 2. Which of the following options is are correct regarding predicted execution? Choose the most appropriate option. In predicted execution, a thread processes instructions belonging to both the directions of a branch instruction. The instructions on the correct path are allowed to modify the architectural state. The instructions on the wrong path are not allowed to modify the architectural state. Here all options are correct. So I select all of these. Okay. So I select all of this. Now moving into the next question, question number 3. A point of reconvergence is an instruction that is on the dash path of dash in a warp. The options are correct and all the threads, wrong and all the threads, correct only the first thread, wrong only the first thread. So here first option will be the correct answer. A point of reconvergence is an instruction that is on the correct path of all the threads in a warp. Okay, so I select that one. Now get into the question number 4. Match the following: temporal locality and spatial locality. Temporal locality will match option P. Repeatedly access the same memory locations over and over again in a small interval of time. And temporal locality also will match with option R, create a memory hierarchy. And spatial locality will match option Q, a pattern where we access nearby objects in a small interval of time. And in a cache, store data at the granularity of blocks. A block is treated as an atomic unit. So here 1 will match with P and R, 2 spatial locality will match Q and S. So this will be the answer. Okay, so I select. Now moving to the next question, question number 5. A 32-bit memory system uses a direct mapped cache with a block size of 64 bytes. The total size of the cache is 64 KB. How many bits are used for the tag, index and the byte offset respectively? Okay. This is a figure of a direct mapped cache. In the case of a direct mapped cache, we index the tag and data array bits using the n least significant bits of the block address, where 2 to the power n is equal to the number of entries in array. Now we are given here the block size of 64 bytes, which can be represented as 2 to the power 6. So therefore used for the byte offset. Also, the cache has 1024 bytes, which can be represented as 2 to the power 10. So, next 10 bits of the memory address are used for the index. Now, the remaining bits of memory address are used for the tag. The system memory here uses 32 bit. Okay, so tag size will be 32 bit minus index bit minus offset bit. Okay, so 32 bit minus index bit 10 and offset bit 6. So 32 minus 16. So tag size will be 16. Okay, so here 16, 10, 6. This will be the answer. Okay. Now moving to the next question, question number 6. Match the following: SRAM cells, CAM cells, CAM cells. SRAM cells will be matched with option P, direct mapped cache, and also mapped with set associated cache. Our CM cells will be matched with tag array in a fully associative cache. Okay, so 1 PQ and 2 R. Okay, So I select. Now get into the next question, question number 7. Arrange the following steps involved in the cache read operation in the correct order. Options 1. Look up the tag array and read all the blocks of the set in parallel. Option 2. If there is no empty line, evict a block in the set of create space for the new block. If there is a miss, read the block from the lower level and find an empty line in the set. If there is a hit, choose one of the read blocks. So here 1 4 3 2, 1 then 4 3 then 2 will be the correct order. Okay, so I select this one, 1 4 3 2. Now question number 8. Match the following: write through scheme and write back scheme. Here write through scheme will be matching with option P and Q. Propagate every write to the lower memory level, can perform seamless eviction of a block. And write back scheme will be matched with option R and S. Set the modified bit to 1 if there is a write access to the block, and at the time of eviction, if the modified bit is set to 1, write the block to the lower memory level. Okay, so 1 will be matching with PQ and 2 will be matching with RS. So this will be the answer. Okay, so I select that. Now moving to the next question, question number 9. Which strategy reduces the average memory access time AMAT? Choose the most appropriate answer. Options are reducing the hit time, increasing the miss time, reducing the miss penalty, reducing the miss rate. Here option 1, 3, 4 will be the answer. Okay, so I select this one. Now moving into the next question, question number 10, which is the last question of this assignment. Let's check. Which of the following statements are correct? Statement 1. Virtual memory solves the overlap problem by mapping pages to frames such that there are no overlaps. Virtual memory solves the size problem by creating an array of frames in the hard disk called the swap space. And in that case, both statements are correct. So this will be the answer. Both S1 and S2 are true. Okay, so I select. So friends, I have completed this assignment. Hope this is benefited to you. Please subscribe this channel, like, comment if any, and press the bell icon to get the notification of upcoming videos. Thank you. Jai Hind.